Hello students, welcome back. So we're going to talk about the concept of elasticity today. Now, before we begin, I want to make clear that the concept of elasticity is pretty simple and straightforward. And economists use elasticity, and it's a measure of the slope of the supply and demand curve to express how buyers and sellers will react to changes in price for a good. And you can imagine this is really valuable information. We talked a little bit about how elasticity could inform policymakers who are interested in changing tax rates to see how it would affect the market, whether it would generate more tax revenue or it would cause more deadweight loss. Those are important questions. But this is also important, as you can imagine, for businesses. So for example, if I was working for a clothing retailer and I was considering changing the price of the clothing that we manufacture, the jeans or the t-shirts, I'd kind of want to know if I increase the price by $1 or $2, how many consumers are likely to stop buying the good and switch to something else. So the sensitivity of buyers to price changes is really valuable for all sorts of businesses, and there's a lot of time and effort by economists that work for businesses trying to estimate elasticity. Now, you might ask the question, why don't they just measure the slope instead of measuring the elasticity? And it's a good question. You're going to find out that slope does not equal elasticity, even though the two concepts are closely related. And elasticity is a lot more complicated to calculate than slope. So you might ask yourself, well, why go through the trouble? Well, we focus in the case of elasticity on percentage changes. And this really gets at a deeper issue, which is, what's the best way of measuring how consumers respond to changes in prices over time or across countries? So if you measure the slope of a demand curve, for example, just using the dollar values today, then as inflation happens over time, the value of a dollar changes. But the percentage change would remain constant. If I move from $10 to $12, then I've changed the price by 20% at that time. And if I change from $5 being the price to $6 being the price, I've also changed it by 20%. Now, what might happen, right, is if I'm taking measurements of how people respond to changes in price in 1970, maybe a pair of jeans only costs $5. Well, in the year 2019, $5 won't even buy you a burger. So there's been significant inflation. But if I really think the underlying responses of consumers are the same, regardless of whether or not they were faced with a price change in 1970 or a similar price change in 2019, then if I do everything in percentage terms, I'll more likely be able to uncover what the underlying behavior is, because the percentage change won't be contaminated by the units. It won't be contaminated by inflation. By units, I mean the 1970 dollars versus the 2019 dollars. They're not the same units because they have different purchasing power. So, and also, if you were to move across countries and say, I'm a company that sells pants in Europe and I sell pants in the United States, the euro is worth a different amount than the dollar. Can I use data from my sales in Germany to predict how consumers are going to behave in America? Well, if I'm going to do that, I better make sure that the change the consumers are experiencing in Germany from a price increase is the same. So if I do it in percentage terms, then there's some reason to believe that the data might be meaningful regardless of where they're applied, even though a euro isn't the same as a dollar. So with all that said, there is a payoff to the complexity that we're going to embrace in trying to measure the slope. Okay, there are a bunch of different elasticity measures, and the one that's the most important for this class, the one we'll talk about most, is the price elasticity of demand. And it's going to measure how much the quantity demanded of a good responds to a change in the price of that good. The price elasticity of demand is simply the percentage change in quantity demanded for a given percentage change in the price. So what affects the ability of certain goods to be substituted for others? Well, really, if you look at all of the items that we're talking about here, the real issue is whether or not there's a close substitute available. So if we talk about necessities versus luxuries, well, necessities are things you really need, like maybe your medicine. If you're diabetic, you need your insulin. And so in those cases, you wouldn't be willing to substitute much for your insulin because you need it. But it's also the case that there are no close substitutes available. And so for luxuries, it tends to be the case that people are very sensitive to price changes. If you increase the price of a yacht by 20%, and then people buy many fewer yachts, there's just data on that. But that's because there are lots of things people can do to substitute their luxurious consumption items. If they're buying expensive shampoo, they can trade down to cheap shampoo. If they're buying a yacht, then maybe they'll buy a plane instead. So there are lots of different things you can do with luxuries. There are lots of substitutes available. And the definition of the market, well, if you include a really narrow category of goods, like you say Diet Cola, right? Well, then there might be lots of substitutes available for Diet Cola. So you'd imagine that consumers would be very responsive, what we would call an elastic response, right? But if you define the market broadly to include like all sodas or everything that you can drink other than milk and water, then there aren't many substitutes available, and demand tends to be inelastic when you have a broad market definition. Time horizon also matters too. If you talk about the demand for gasoline over the next week, then people tend to be pretty rigid in their purchase of gasoline because they don't have time to form carpools, maybe purchase a car that's more fuel efficient. So if you measure demand at a very short time horizon, it tends to be inelastic. There's not much responsiveness. But if you measure it over a long time horizon, then people can come up with strategies to substitute. So again, they can take the bus, they can find out the bus schedule in the case of gasoline, and they can form carpools. They can decide they want to ride their bike on certain days, or they can switch to electric vehicles. So if you measure the demand for gasoline over a long time horizon, like a year or 6 months, then you're going to notice that the demand looks a lot more responsive. It's going to look a lot flatter as a curve, not as steep. Okay, so demand tends to be more elastic when there are a larger number of close substitutes, if the good is a luxury, if you have a narrowly defined market, and if you have a long time horizon. Okay, so the price elasticity of demand is computed as the percentage change in quantity demanded divided by the percentage change in price. Now, this is the equation. The real sticking point here is that how do we calculate these percentage changes? Because we're talking about moving from one point on the demand curve to another point on the demand curve. So should we use the starting point as our base for the percentage or the ending point? Well, what you'll find out is economists use a method called the midpoint method or the arc elasticity method, which uses the midpoint of the range as the base for calculating the percentages. So here's the question. So if the price of an ice cream cone increases from $2 to $2.20, so we've moved from one point to another, and the quantity that's purchased falls from 10 to 8 cones, then if we calculate the elasticity of demand, we'd get the following calculation. If we used the starting point, right? Our quantity would be 10 and our base would be 10. And we take the difference, the change from 10 to 8, divide it by the starting value, which is 10. And we use the difference in the prices and the starting price of 2. So we're using the starting price and the starting quantity as our base. And we calculate this 20% over 10%, which is a value of 2. Now, when you get the value of 2, you can just ignore the percentages. It's just 20 over 10 is 2. But if you were to write them as decimals, it'd be 0.2 over 0.1, which is also 2. So because we don't want to bias our calculations by picking one of the points over the other, we get this different method of doing it, which is using the midpoint. And the midpoint is preferable because regardless of which direction the change is in, we'll end up with the same value. Hopefully you could see on this last example that if we had used 8 and $2.20 as our base for the percentages, then our value for the elasticity would have been different. And we want consistency, whether you're going from one point to another or starting at that point and moving backward. So the midpoint formula will give us that consistency because it doesn't matter which point we say is the starting point, whether it's 0.1 or 0.2. So you can see here, and we'll talk about this a little bit more, right? So you start at 1 point and you label that as 0.1, so that's going to be associated with Q1, the quantity 1 demanded. And this is the formula you should pay attention to and write down. And Q2 is the second point. And then for the base, we take the average of those points, which is Q2 plus Q1 divided by 2. And for the prices, likewise, we take P2 plus P1 divided by 2. And it turns out that that quantity, Q2 plus Q1 divided by 2 and P2 plus P1 divided by 2, is the midpoint of that range we're focusing on. So again, if we go back to this ice cream example, if we use the midpoint method, then we end up getting an elasticity of 2.32. Okay, and that's the one that we would be calculating for this class. Hopefully you can follow all of the calculations of the percentages just fine based on the example that's given. So the variety of demand curves. The quantity demanded does not respond strongly to price changes if the demand is characterized as being inelastic. Price elasticity of demand in this case for an inelastic demand curve would be a price elasticity of less than 1. And if you think about what that means, it's going to mean the percentage change in quantity is less than the percentage change in price. So for example, if I raise price by 10%, then the quantity demanded falls by less than 10%. So people don't react very much. And if the demand is elastic, the quantity demanded responds strongly to changes in price, and you end up with a price elasticity of demand that's greater than 1. So let's take a look here at a couple of examples. We're going to compute the price elasticity of demand for this range of the demand curve between prices of $5 and $4. So you can see the quantity demanded is changing from 100 to 50. So we take the difference in the elasticity of demand calculation in the numerator, and then we'll go ahead and divide it by the sum of those quantities, 100 plus 50 divided by 2. And 4 minus 5 is a difference of $1. And notice that the calculation ends up with a -3, right? And in terms of absolute value, that's how we're going to characterize whether or not we're talking about an elastic or inelastic demand curve. This demand curve comes up with, in that range, a value that's greater than 1 in absolute value. So we would say that the price elasticity is elastic. Demand is elastic in that range. Okay, so hopefully as you look through these calculations slowly, maybe you want to pause the video. You should be able to follow the math. It's pretty straightforward. There are only 4 numbers involved, and they come the difference in the prices and the difference in the quantities. Okay. So when we talk about elasticity, there are a couple of different categories that curves get lumped into. And so one of them is perfectly inelastic. Now, a perfectly inelastic demand curve is vertical. It means as you change the price, the quantity stays exactly the same. And a perfectly elastic demand curve is horizontal. And if you think about that, what it means is that if I change the price a little bit, the quantity demanded is going to change enormously, infinitely. And then we also have this other category of unit elastic demand curves. And this is kind of like a sweet spot in between. It's not less than 1 in absolute value or greater than 1. Because remember, in the case of demand, our elasticities are going to come out to be negative numbers. But a unit elastic demand curve would have an elasticity of -1. And what that means is the ratio of percentage change of quantity demanded to percentage change in price is equal. So if you have a 10% increase in price, you have exactly a 10% decrease in the quantity demanded. So unit elastic demand curves are special, or if you find a region of demand curve where it's unit elastic, that's a special thing because your change in quantity is going to exactly mirror in percentage terms your change in price. So because elasticity of demand measures the quantity demanded and how it responds to change in price, it's closely related to the slope of the demand curve, as we've talked about. So we'll illustrate a couple of the cases that we talked about just a moment ago. One is this perfectly inelastic demand curve, and demand is then a vertical line, right? Regardless of what the price is, the quantity demanded is going to be exactly the same. And here you can see the price is increasing from 4 to 5, and the quantity demanded is unchanged. And in that case, the elasticity of demand, if you calculated it, would be equal to 0. So an inelastic demand curve looks relatively steep. This isn't a straight line, but hopefully you can see it's relatively steep. And here, if we were to pick 2 points and calculate the percentage change in price and the percentage change in quantity demanded, here you can see the percentage change in quantity demanded is only 11% in this illustration in response to a 22% increase in the price. So that's going to give us a number that's in absolute value less than 1. A unit elastic demand curve is one where we end up with this opposite result, which is, as illustrated here, it looks relatively flat, and 22% increase in the price is generating exactly a 22% change in quantity demanded. So elasticity is going to be equal to 1 in absolute value. And here, in an even flatter demand curve, we look at the same percentage increase in price, and we're going to get this really big response, a 67% change in the quantity demanded. And that's going to give us a number that's greater than 1 in absolute value. 67 over 22 is about 3. Okay, and then we've worked through this from steep to not as steep to in between to flat, and now we have the flattest example, which is a horizontal demand curve. This is what we would call a perfectly elastic demand curve. And now you can see at any price above 4, demand drops to 0, and at 4 or below, an infinite quantity would be demanded. I mean, you can't see the demand curve going off into infinity, but the point is, once you change to 0, if you try to do your calculation, you're going to end up with something that doesn't compute because you're going to be dividing by 0 in the percentage change in price. And anyway, bottom line is that elasticity ends up to be a really, really big negative number and in absolute value, it's infinity. Okay, so that's what a perfectly elastic demand curve looks like. Now, one of the major topics that we're interested in is discussing about the relationship between revenue and price elasticity. So I think there's enough for this lecture, and so I'll stop here and we'll talk about this topic of how we can relate revenue for a business, not tax revenue, but revenue for a business to information about price elasticity of demand for the product. Okay, thanks, and I'll be talking to you soon.